Okay, this is the study guide for the final exam for pre-calculus. This will be part 1. There'll be probably a couple more parts after this, and we will do our best to get through all of it within a good time period. But if it goes long, you can always fast forward through and just do the problems that maybe you are struggling on. The final exam will be multiple choice, but the question setup will be similar to this. So I tried to give you a bunch of different ways I could give you a log problem. You need to write down and remember all your log rules. The first log rule says if this says log base 9 of something equals log base 9, you can just set these two equal to each other. So 2a plus 5 equals 3a. So a must equal 5. Same thing over here. We can set these two equal to each other. And since it's an n squared, I would set it equal to 0. I put the 0 on this side since that's positive. So n squared minus 4n, and then add 1 would be minus 5. And then obviously you can factor it. And you get n minus 5 and n plus 1 factored. And then when you set them equal to 0, you get n to be 5 and negative 1. Well, the only problem is negative 1 doesn't work because when I plug it back into the original, this inside of the parenthesis next to the log would be negative, and that can't work out. So 5 is the only answer. Okay? Now this is 2 logs are on the same side as opposed to on 2 opposite sides. You need to condense this. Condense with addition of logs is actually multiplication of what's next to each other. So the log base 8, keep the log, and then just multiply those together. X squared plus 12x equals 2. And then 1 log, one side, you zoop. So I would go 8, wrap it around, and point. So this becomes x squared plus 12x equals 8 squared, which is 64. And again, set it equal to 0 and factor. And 2 numbers that multiply to 64 but make 12 would be 16 and negative 4. And then when you set them equal to 0, you get negative 16 and positive 4. Well, again, one of them is extraneous, and that's the negative 16 because it would cause this to be negative. So the correct answer is 4. All right. Same idea. 2 logs, I'm subtracting. I need to condense them. So we write subtraction of logs as division. And then when I see 1 log on one side, I zoop. 2x squared over 4 equals 4 to the 3rd power. So this reduces to like 1/2, or x squared over 2 equals 512. And then you can multiply by 2. You get x squared equals 1024. And then take a square root, and it would be plus or minus 32. And actually, both of those can work because the x is being squared. So both of them will work. All right, now I'm solving for an exponent a variable inside the exponent, excuse me. First, you want to get this exponential part by itself. So you're going to add 6 over, get 4 to the negative 6r equals 96. Well, 96, we can't make it a base 4. You know, you can check it if you want to, but 4 to the 3rd is 64, and then 4 to the 4th is 256. So we need to ln both sides. And when you ln, remember this comes in front, and you get negative 6r, the ln of 4, equals the ln of 96. And then you're just going to solve for r and divide out negative 6 and divide out ln of 4. And then you can put this into your calculator. The ln of 96 divided by, and you would want to put it in its own parentheses, negative 6 ln of 4. And negative 0.548 is the correct answer. And we're going to do the same thing with number 6.
Oh, I'm so sorry.
And you would have 5 to the 6b equals 70/4, which 70/4 is 17.5. And likewise, we can't get this to be a base 5, so we're just going to ln both sides. And then the 6b will come down, the 6b will come down in front of the ln 5 equals the ln of 17.5. And again, we're solving for b, so we can divide out the 6 and the ln 5. And put this one in your calculator just like that, and you'll get about 0.296. All right, and then 7 and 8 are e problems. Again, you want to get the e with the exponent by itself, just like you did this. So you would have e to the n minus 6 equals, subtracting over 4 is 46. You're going to ln both sides because that's what gets rid of an e. You get n minus 6 left on this side equals the ln of 46. And then you're just going to add 6 over. Now, I will say be very careful when you type this in because you're doing the ln of 46. Close the parenthesis, then add your 6 on over. And that's the answer. If you don't close the parenthesis, it's going to be taking the ln of 52. So it's 9.82. And then dividing -4 over first for this one, you get e to the x plus 3 equals 5/4, which I'm just going to call 1.25 because it's a terminating decimal. And I'll do the same thing I just did over there. ln both sides. You get x plus 3 equals the ln of 1.25 and then minus the 3. And again, ln 1.25. And then you're going to subtract 3 after you close the parenthesis. You get -2.78. So that's all you have to remember for logs, okay? Now, convert each radian measure into degree and then convert degree to measure. So if you're going from radian to degrees, you multiply by 180 over pi. So you might want to write that down, 180 over pi. But if you're going from degree to radian, you multiply by pi over 180. Remember, this is over 1. So times pi over 180. But when you put this in the calculator, okay, these will cancel. So you don't have to put them in there. You just do 8 times 180 and then divide by 3. And that would be 480 degrees. Same thing here. 4 times 180 divided by 3, which is 240 degrees. Now this one, though, when you put it in the calculator, don't put in pi. Just put the 120 on top, divided by the 180, and you can hit math frac and let it reduce it, so 2/3, and then put the pi next to it on top, so 2 pi over 3. Same thing here. So -870 divided by 180, math frac, -29/6, and put the pi next to the top. And that's how you convert it to radians. Okay? Draw an angle with the given measure in standard position. So -130, remember going counterclockwise is positive, going clockwise is negative. And this is 0, this is where you start. And you have like an original side right there, and then you're going to go -130. This is -90. This is -180. So -130, would be right about here. And so this would be the quadrant that you're drawing it in. -360 would wrap that way and land back there. That would be -360. All right. Next page. Now find the measure of each angle. So if this is 2 pi over 3, if this section is 2 pi over 3. And this way, okay, so we've gone 1 full pi, and then we've gone another 2 pi over 3, it looks like. So this is 3 pi over 3. And then I've gone another 2 pi over 3. Then this position here must be 5 pi over 3. Okay? Likewise here, if I'm going, this portion right here is pi over 3, which is, again, if you don't remember, sometimes I convert it to degrees in my head. That's 60 degrees. This must be 30 degrees. 30 degrees, which is pi over 6, because together they have to make 90. But again, watch what I do. I wrap all the way around, all the way around, all the way around, all the way around. So that's I've done 1 full circle, which is 2 pi. Plus I've gone another pi over 6. Well, 2 pi plus pi over 6, that's the same as saying, remember anything with the denominator 6, this would be 12 pi over 6. 12 pi divided by 6 is 2 pi. Plus another pi over 6 would be 13 pi over 6. All right, now we got to find the reference angle. Remember, reference angle is an acute angle. It can't be negative. And you're either closer to 360 or 180. Okay? And how far away are you is really the question. So if I'm 240, well, if I take away 180, I'm at 60 degrees, which is an acute angle. Negative 470, I would add a coterminal to that because I like dealing with smaller numbers. So I would just be like negative 470 plus 360 is negative 110. I would even add another 360. So it's the same as 250. So is 250 closer to 360 or is 250 closer to 180? Well, it's obviously closer to 180 by 70 degrees. How about radians? Radians is super easy. Whatever that is. Whatever. Don't even worry about the 7 in front. Don't worry if this one, it's pi over 6 is the acute angle. If this was over 3, pi over 3. Pi over 4. Super easy. All right, find the value of the trig function indicated. So again, this is just testing you on SOHCAHTOA and its reciprocals. So if I'm standing here at theta, they've given me an opposite and a hypotenuse. Well, I want to find the tan. Tan is opposite over adjacent. So I need to know how to find this. So you can use either your knowledge of triangles. This is 12 to 6 root 3. So you would use Pythagorean theorem. And this would be 6. So the tan of theta is equal to opposite over adjacent, 6 root 3 over 6. Or just root 3. So tan theta is square root 3. This one, again, this is a right triangle. This is 3, 4, 5. So if I want the cosecant, cosecant's reciprocal is sine. So cosecant is just hypotenuse over opposite. It's just the reciprocal of sine. So again, if I'm standing here, hypotenuse would be 5, opposite would be 3. That's the cosine of theta. All right, in each triangle ABC, angle C is the right angle. Find the value of the trig function. You've got to draw these. You've got to draw these. So we're going to draw a quick right triangle like this. We're going to put C as the right angle, and then A and B doesn't matter. And I'm going to do that for this one over here too. So we're finding tan if little side A is 12. So little side A is opposite angle A. And little side B is 12. That would be opposite here. Using Pythagorean theorem, this would be 12 square root of 2. But you didn't really have to find that because all you need to know is tan of A. So if I'm standing at A, tan is opposite over adjacent. Tan of A is 12 over 12, or 1. Tan of A is 1. Same thing here, okay? Little side C is opposite C, that's 15. Little side A is opposite A. Using Pythagorean theorem, this would be 9. I'm skipping that part, but you should know how to do Pythagorean theorem. So now you're going to stand at A and you're going to find the cotangent. Well, cotangent is the flip of tan. Tan is opposite over adjacent. Cotangent would be adjacent, which is 9, over opposite. And that simplifies to 3/4. All right, and then now this one, we're going to find the measure of each angle indicated. So we're going to stand at theta, and you're going to look to see what they gave you. They gave you an opposite, and they gave you an adjacent. Well, opposite and adjacent is tan. So you're going to write tan of theta equals 13 over 12. Since they asked us to find the angle, we use inverse tan, but make sure your mode is in degree. And now use inverse tan of 13 over 12. 47.3 degrees. And we'll do that again here. Stand at theta, opposite, adjacent. Oh, they did that again. Tan theta, 11 over 10. We're going to inverse tan, 11 over 10. And we get 47.7 degrees. I'm going to stop this right there. I'll have another part done for you in a few minutes.